All right, the slope-intercept form of a line is y equals mx plus b. You can always tell if it's in slope-intercept form because it's in that form. What that really means is, I can type that in there real quick, I will. What that really means is it is in that form. The y is solved for. There is a number in front of the x and something being added or subtracted at the end. So in this case, the y is solved for. That y is by itself. The m is my slope, and my b is my y-intercept. And those are the two things that you need to know in order to write an equation. You need to know the slope and the y-intercept. So this is a true or false. If you are given an ordered pair and the x-coordinate is 0, the y-coordinate is the x-intercept. And remember, when you're given an ordered pair, it's always going to be y comma or x comma y. Okay, so if that first number is a 0, that's true. The second number is the y-intercept. So in this case, that first number is a 0. My y-intercept is -2. The letter M stands for slope. The letter B stands for y-intercept. Let's do a couple examples. So we want to write the equation in slope-intercept form with a slope of 3 and a y-intercept of -2. And if you noticed, I already wrote down what the important stuff was as I'm reading it. It needs to be in slope-intercept form, so that's y equals mx plus b. And what I'm going to be substituting in is my m and my b. Those are always going to be the two things that I want to make sure that I put in. So y equals, now instead of m, I'm going to put in 3. Copy my x. Instead of b, I'm going to put -2. And that's all there is to it. That's my equation. On the next one, I'm given a slope. And I automatically look at this and I know the slope is negative. Remember, if it's pointing up and to the left, that's a negative. And since they're giving me a graph, I'm going to use rise over run. My rise is 2. My run, because I'm going to the left, is -2. So rise over run. And if I simplify that, it's just going to be -1. If I'd wanted to, I could have started at the other point. I could have gone here and gone down 2. And that would have been -2 because I'm going down. Right 2. In that case, my rise would have been -2 over 2, which is still -1. So my slope is going to be -1. Let's go ahead and write that in. My y-intercept, that's where it's crossing the y-axis. So find your y-axis, and you can put a dot there. So it's going down 1, 2, 3. So -3. That's a little fat. Let's go ahead and make that a little skinnier. So my y-intercept is -3. So I'm going to go back to my equation, y equals mx plus b. Y equals -1x minus 3. You can leave it as that -1x, but it's kind of awkward. The better way to write that would actually be y equals -x minus 3. All right. Hit pause. You try these two on your own. If you need to, rewind, go back, look at examples 1 and 2. They're the same type. Follow that as an example. All right, let's take a second and talk about horizontal lines. So if I want to draw an example of a horizontal line, here's my coordinate plane system. And we'll draw this in red. We'll get fancy, we'll even do a line. Horizontal lines go across. Think of like the horizon. The slope of a horizontal line is always going to be 0. The equation of a horizontal line is always going to be y equals some number. The way I always remember it, it needs to cross through that y-axis in order to be horizontal. If it crosses through that x-axis, not going to be horizontal. A horizontal will have a y-intercept, but no x-intercept. The only exception to that is if you had y equals 0. An example of a horizontal line is y equals 2. So I paused there for a second. I'm sorry about that. An example of a horizontal line would be y equals, and it could be any number. So if I wanted to write the equation of this one, I notice that my y-intercept is 5, and my y-coordinates are both 5. So here, the equation would be y equals 5. Try the second one on your own. You might want to hit pause for a second. All right, vertical lines. If I wanted to give an example of a vertical line, here's my coordinate plane system. And a vertical line is going to go up and down. The slope of a vertical line is always undefined. The equation of a vertical line is always going to be x equals some number. And for a vertical line, you're going to have an x-intercept, but no y-intercept. Again, the only exception on that would be if you had x equals 0. An example of a vertical line is x equals, and you can put any number in that you want. I'm going to choose -1. So let's go ahead and do a couple. Here, looks like my y-intercept is 3. I'm sorry, did I say y-intercept? I meant to say x-intercept. My x-intercept is 3, so it is x equals 3. Take a second, pause, do the next one on your own. All right, so sometimes we need to find the slope between 2 points. So if we're given 2 points, x sub 1, y sub 1, x sub 2, y sub 2, and those sub 1s just are a way of telling them apart. This is my first ordered pair. This is my second ordered pair. In an ordered pair, it's always going to be x comma y. You're going to use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is a formula you probably want to put into the memory banks. And that'll tell you your slope. If you're given a graph, you probably use just the counting method and do rise, how much it goes up and over, run, how much it's going right or left. So let's go ahead and do a couple together, and then I'll give you a chance to do a couple. If you're a visual person, you might want to label x sub 1, y sub 1, x sub 2, y sub 2. That's just order it, giving values to my ordered pairs. So my x sub 1 is 8 because it's listed over the 8. My y sub 1 is 10 because it's listed over the 10. My x sub 2 is negative 7 because it's listed over that. And my y sub 2 is 14. And I'm just going to plug things into this equation. So I'm going to start right there with the y sub 2, which is 14. And then I do a minus sign. And my y sub 1 is 10. Then I'm going to draw my fraction bar. Start here. My x sub 2 is negative 7. Do a minus sign. My x sub 1 is 8. I want to be very careful of signs here because it's really easy to make a mistake. 14 minus 10 is 4. Negative 7 minus 8 is negative 15. It's kind of awkward to leave that negative sign down in the denominator, so I would just usually put it out in front. Negative 4 over 15. Let's do another one together. That would be x sub 1, y sub 1, x sub 2, y sub 2. And you're just going to plug them into that formula. Your y sub 2 is 2. Then you do a minus sign, and your y sub 1 value is 1. Now we're going to do our x's, difference of our x's. Negative 17 minus negative 3. Be careful not to just put negative 17 minus 3. We have to have two minuses because it's always minus that value. And in this case, we have another negative because it's negative 3. So that's going to give me 1 over negative 14, which would just simply be negative 1 over 14. You are probably going to get a lot of fractions on this, and that's okay. So let's go ahead and do this one. We're not even going to label it this time. Difference of my y's, 10 minus negative 4. Difference of my x's, which are my first values, negative 12 minus negative 20. And again, you want to be really careful of those signs because it's easy to make a mistake. And that is going to give me negative 6 over 8, which we want to reduce that to negative 3 force. All right, there are 5 more here for you to do. Hit pause and do those 5 slopes on your own. If you need to, go back up and hear the explanation one more time. Oops. Needed to scroll down a little bit further. Let's talk about point slope form of a line. The best time to use point slope of a line is when you are given the point and a slope. And the point is always going to be some ordered pair, x sub 1, y sub 1. Okay? So when I talk about a point, I'm talking about an ordered pair, x sub 1, y sub 1. The point slope form is y minus y sub 1 equals m times quantity x minus x sub 1. And what you would actually be substituting in there are your ordered pairs, x sub 1, y sub 1, and your m. So in order to know this, or to use this form, you need to know a point, which again would be x sub 1, y sub 1, and the slope, which in this case is your m. The difference between slope-intercept form and point slope form is kind of a subtle little difference. They both tell you the equation of the line, but slope-intercept form has the y solved for. So slope-intercept form is always going to be y equals. So you really have to look at how it is written. So to change a line from point slope to slope-intercept form, what you need to do is you need to distribute the slope and then either add or subtract the value that is with the y on the left-hand side. So let's go ahead and do one together. So again, I'm going to put that form up here just because it's a good habit to get into, of having that equation written down for you. Y minus y sub 1 equals m times x sub 1. Oops, not x sub 1. X minus x sub 1. So they want the line in point slope form. It passes through 4, 2. So that's my x sub 1. That's my y sub 1. And has a slope of 0.5. So let's go ahead and put that in there. Y minus my y sub 1 value is 2. My slope is 0.5. Then you just put x minus, and my x coordinate is 4. Okay, that's what it is in point slope. You don't have to do anything else. Here, it says to put it into slope-intercept form. So we're going to start with where it's at. Y minus 2 equals 0.5 0.5 times x minus 4. Well, here it says that I need to distribute and then add or subtract. So I'm going to start by distributing. So y minus 2 equals 0.5 x minus 2. And it says it needs to add or subtract the value that's with the y. Well, in this case, I have a minus 2, so I need to plus 2. Well, it looks like that's going to cancel everything out. And what happens is I'm going to be left with y equals 0.5 x. What that means is when it cancels out, my y-intercept is 0. All right. There are 2 more for you guys to try right there. Why don't you hit pause and try those 2 on your own? All right. Sometimes, though, they want us to put, they don't give us all the information. They're just going to give us through 2 points, okay? So it doesn't look like I gave myself quite enough room here, so let's see if I can maybe give myself a little bit more room. Tell you what, I'm going to just cheat here for a second. So I've given myself 2 points, and I want to write an equation. However, I don't know the slope, but we're now smart enough we can figure out what that slope is. We've done that before, not that long ago, where if you want to find that slope, you take the difference of your y's over the difference of your x's. So in this case, -1 minus 2 over the difference of my x's. 0 minus -3. And again, I want to be really careful of those signs. And what happens is I'm going to get -3 over 3, which is -1. So my slope is -1. Now I need to choose a point. I'm just going to choose that point. So that tells me my x-coordinate. That 2 tells me my y-coordinate. So I'm going to use point-slope form because I have a point and a slope. So I'm going to get y minus 2 equals -1 x minus -3. And I put +3 because it's minus and negative. 2 negatives make a positive. Well, I want to make this look nice and pretty, so I want it in slope-intercept form, so I'm going to have to distribute. And then add 2 to both sides. And when I get done, I'm going to get y equals, and again, I could write -1x, but writing -x is better. -3 plus 2 is -1. I'm kind of curious if anybody realized, hey, I just did extra work, because I knew what the y-intercept was going to be. That x-coordinate is 0. That means the next y-coordinate is my y-intercept. I did a little extra work. I could have, if I'd been smart, I could have looked at that and gone, hey, there's my y-intercept right there. It's -1. All right, go ahead and hit pause. Try to do the next one on your own. If you need to, go back and hit rewind and watch the example again. All right, so let's talk about parallel and perpendicular lines. Parallel lines don't cross. Don't know that those are the best parallel lines, but you kind of get the idea. Perpendicular lines cross at 90-degree angles. Lines that are parallel always have slopes that are the same. To find a slope that is perpendicular, first change the sign. So if it's positive, make it negative. If it's negative, make it positive. And then take the reciprocal. And what that really means, if I'm taking the reciprocal, is you want to flip it. Okay? So take the reciprocal or flip it. So let's go ahead and just do a few examples. Here, my slope is -5. And I know that because it's in slope-intercept form. Y equals mx plus b. So the slope of any line parallel to it would be the same, which in this case would be -5. And if I were to flip that, that's really -5 over 1. So it'd be 1/5 for perpendicular. Let's go ahead and do another one. Again, this was given to me in slope-intercept form. So the slope here is -2/3. Again, it's written in slope-intercept form. The slope of any line parallel to it would be -2/3. And the slope of any line perpendicular would be the opposite sign, positive, 3/2. All right. Try the next two on your own. You might want to go ahead and hit pause. So here I want to write an equation in slope-intercept form. So I need to make it look like y equals mx plus b. And it needs to be parallel to 2/3. So there is my point and my slope. I'm going to start with point slope form. Y minus y sub 1 equals m times x minus x sub 1. And I know to use that one because they're giving me a point and a slope. So let's go ahead and plug in what we know. My y coordinate is 0. Oops, did I put an equal? I'm going to put a minus. So y minus 0 equals my slope. For parallel, it's the same, so 2/3. X minus 2. Well, I need to make that look pretty. And this is going to be easy, this part. Y minus 0 is just y. And then I need to distribute 2/3 times x is just going to be 2/3 x. 2/3 times 2 is 4/3. If you wanted to, you could put that 2/1. Numerator times numerator gives me 4. Denominator times denominator gives me 3. There's nothing to add or subtract with the y. That's going to be my final answer. Go ahead, hit pause. Try the second example by yourself. All right, this last one is perpendicular. So my slope is negative 2/7. That means my perpendicular, remember that's the sign for perpendicular, my perpendicular slope is going to be the opposite sign, so positive, and flip it, 7/2. And that's the slope I'm going to use when it's perpendicular. So we're going to use that formula right here, y minus y sub 1 equals m times x minus x sub 1. So y minus my y coordinate equals my slope x minus my x coordinate. We want to make that look nice and pretty. So y minus 4 equals 7/2x minus 7. Add 4 to both sides. And you get y equals 7/2x minus 3. Go ahead and hit pause and try that last example on your own.